All right, so hello everyone. Welcome to the webinar for Nokia Private LTE for Utilities. Thank you for joining us. My name is Danielle Corley, and I am the Sales and Product Manager for Access Wireless Solutions, and I will be your moderator today. Before we start, I just wanted to go over a few things. If you do have any questions during the presentation, please add them to the chat box, and we'll have a Q&A session at the end of the presentation to address them all. Please also keep your microphones on mute during the presentation. This presentation is being recorded, and we will send out a copy along with the presentation deck. It's an hour long time frame. Please do stay till the end because we will be picking an attendee to win a $25 DoorDash certificate. We're thrilled to have you here. We have some excellent information that we're going to be going over about private LTE for utilities. We're very excited to introduce our new partnership with Nokia, and now we can offer our customers a private LTE solution to meet all of your connectivity needs. We have two presenters today. First presenter is David Schwartz. David Schwartz, president and founder of Wireless Data Solutions. He is one of the industry pioneers, being on the forefront of the utilization of wireless data communications technology to address real-world business requirements since the late 1980s. Prior to opening Access Wireless in 2008, Dave spent over 30 years in the wireless data industry, having worked for Ericsson, GTE, and Intel in various senior management capacities. Dave currently sits on the advisory committee for a number of the leading OEM device manufacturers, where he contributes to a design and evolution of many of the devices and products commonly seen and used today to address a broad range of applications where remote connectivity is a necessity for both fixed and mobile requirements. Our second presenter is Mauricio Subieta. Dr. Mauricio Subieta is the Energy Segment CTO for Nokia North America. He leads the industrial cybersecurity program and is the technical lead for the private wireless networks for LTE and 5G, Nokia's enterprise division, which focuses on the energy segment, including electric utilities, oil and gas, and mining. Dr. Subieta completed his undergraduate studies in systems engineering at the Bolivian Catholic University in 1997, and his master's and doctoral degrees in telecommunications management and electrical engineering at the Oklahoma State University in 2002 and 2006. He was awarded the Fulbright Scholarship for his graduate studies and was a distinguished researcher at the Advanced Communications and Systems Engineering Laboratory at OSU. His work experience includes a decade as security and network architect at Oklahoma Gas and Electric, more than 5 years supporting the oil and gas industry as a wireless network engineer, and more than 10 years performing research in the cybersecurity, telecommunications, and also teaching graduate level courses at different institutions of higher education. Dr. Subieta's areas of research and expertise cover next generation wired and wireless networking architectures for 5G, network traffic characterization and optimization, protocol design, system development, and cybersecurity for industrial control and system networks. So without further ado, we'll get this presentation kicked off. Dave, over to you.
Thank you, Dan. Sorry about that. My name's Dave Schwartz. I am president of Access Wireless Data Solutions. And I'd just like to take a moment here before we get started to briefly introduce my company. I see a number of our customers, current customers logged in. I also see some names that I'm not familiar with. So just a brief overview on Access Wireless. We've been in business for over 13 years with a singular focus on providing cellular and Wi-Fi based M2M and IoT solutions that are primarily designed to assist our customers to address real world business issues, if they're interested in increasing productivity, reducing operational costs, or simply gaining competitive advantage in the market. Access Wireless has, over its history, spent a tremendous amount of time and energy to evaluate the various device manufacturers, the carriers, antenna manufacturers, And we believe today we have formed strategic relationships and offer products from a collection of industry leaders in the machine-to-machine and IoT market that's unraveled in the industry. Next slide, please, Danielle. 1 2 minutes. So, realistically, the purpose of today's webinar is in response to questions we've been receiving from our customers regarding private LTE. This has really caused us to realize that the depth and intricacies of private LTE, the fact that it's really difficult to go it alone. So we started researching the companies involved in private LTE, and in researching the leadership positions, we decided to align ourselves with Nokia because they're on the forefront of private LTE. Over the past couple of years, there's certainly been a technical evolution in the cellular industry, probably unrivaled in its history. And we've seen a surge in technologies such as FirstNet, 5G certainly coming to market. But realistically, the interest in private LTE is really starting to soar. In today's presentation, we hope to distinguish that CBRS, and private LTE, while used interchangeably, are not the same thing. CBRS refers to the spectrum, and private LTE more so the infrastructure and the application. It's much more than Wi-Fi on steroids, and it's more than a CapEx, OpEx discussion. It's really more user case driven. And with that, I'd like to turn it over to Dr. Subieta.
Thank you very much, Dave. And I appreciate the people attending the webinar today. And I think to Nokia is a pleasure, and we're proud to work with AWS pursuing private LTE and private 5G network deployment for their customers and their specific segment, as that's one of the things that Nokia has been doing for a while now, supporting not only the actual current technologies, but we've been supporting technologies for the last maybe 15 years, back in the day of Alcatel-Lucent, moving towards the smart grid. So that is really one of the things that we'll be going to covering today from a presentation perspective. How do we support Nokia, that is, the utility smarter grid, which is the newer applications and use cases that we'll see during this webinar that are being now being asked by the customers, that are being requested because of new needs, modernization, as well as renewables that are becoming the norm now when it comes to electric utilities, power generation, and power distribution. Also, the fact that we've encountered so many new challenges from a perspective of, either weather events or other types of natural disasters that have impacted the livelihood of a lot of us. And just think about what happened last October with people in Texas, for example. No, last October, just this year, actually. And we had that big freeze that really caused a lot of damage, not only to the homes, but also to the livelihoods of a lot of people. So this requires changes, and this requires the grid, the smart grid, to become even smarter, to become even more reliable, to become a whole lot more flexible to meet these challenges head on and reduce the amount of outages. So the technology around that is really being driven by the challenges that are being faced by utilities. Some of those are listed here, as I just mentioned, and some of those are really more focused on how things were done in the utilities up until a few years ago, where it's really a traditional environment with a specific culture that has really the mindset of trying to keep things running as they are. But the new challenges, the new requirements from power, from homes, the new, changes and evolution that happened because of COVID, for example, that changed the entire landscape of how electricity was being deployed, how it was being controlled, because a lot of people stayed at home and worked from there. Whereas before, a lot of emphasis was put on providing power to big buildings and the downtown areas where a lot of people would be densely moving to work every day. That stopped for 2 years. And now we're still seeing a lot of change going in there. So all of these new challenges, and then on top of that, including cybersecurity threats that are coming from different actors being sponsored by other states, or being just people that want to make a buck out of it, like the ransomware attacks that are so famous now. All of these are challenges that are driving the utilities to do things in new ways. And to do that, we've actually been seeing a lot of use cases that are being required by these utilities in order to meet these new challenges. These use cases go from the traditional type of use cases with SCADA that really are telemetry type applications based on IEC 61850 and other IEEE standards that actually did define how equipment would talk to each other, how you would do machine-to-machine communication, and how you would actually ensure that all the data that was happening in the network would be collected, but in a very traditional way, using very low data rates, because it was very little data. Moving into newer type of use cases, for example, distributed generation and storage. And put those two together because that shows you the big gap that was actually created among the older technologies for equipment that still run legacy applications today with the newer ones. If you look at the wind farms, if you look at the solar plants, all of those new technologies that are generating electricity that in some cases are even privately held are bringing this new, power, this additional power into the grid. And now the utility has to become a different type of entity, where it used to be a top-down a company or organization where you would actually basically sell all the product you created, you generated from the transmission side and the generation side all the way down to the homes. Now it's different. Now the utilities are becoming brokers. They're becoming negotiators of not only the product that they generate and the extra capacity that's being generated by these individual and independent generations that are actually making the model of being a top-down model not so anymore. Now it has to be able to be dynamic and has to be able to meet that challenge of having power coming from different directions, in some cases where they don't even know that it's coming. So that engages the actual distribution automation use cases a whole lot more. Distribution automation is a broader term that encompasses many different types of use cases or many types of applications that ensure that the actual grid will not only survive, but also operate properly. We also see a lot of advanced metering infrastructure use cases in which we're trying to meet the requirements of not only seeing how much the people are using in their homes, but also how can we, the utilities, and I say we because I used to be part of a utility, how those utilities would actually be able to deal with demand and response, right? Demand response is another use case specifically, but the actual engagement with everybody now being able to look at their usage on the handheld devices, those types of use cases now require constant communication. So the list of the actual use cases is quite long, as you can see, with different types of requirements. And looking at what I started explaining about SCADA, where it was really low data rate, very low throughput of traffic, that latency wasn't necessarily a problem because of the, I would say, the technology was used and worked, from the early 90s, if you want to see it like that. Now things are changing. Now we need more reliability on the network. We need to have low latency for the type of use cases that now do PMU data, phasor measurement unit data. That would be the synchrophasors, for example. So the variety on the requirements make a network to have to fulfill these needs in different ways. So we have now a set of use cases that each bring their own characteristics that need to be met, and that have to be, in a way, shared within either all the infrastructure that utility is deploying as a private LTE or a private 5G network, and or covering additional areas where the utility is not either completed deploying their network, because obviously there has to be an infrastructure deployment to ensure that all the assets and all the corners of the service territories are covered, but there's also the financial limitations there, in which in a lot of cases it doesn't make sense to do that. So they have to fall back to traditional commercial carriers that will support communications the old traditional way, say in this case, with using commercial LTE, and merge those two in order to basically reach every single corner of their infrastructure. Having the technology that has been working for us for the last 20 years from a commercial side, where we are very used to it now. I mean, I couldn't really go through the day without my phone, without being connected, is something that was the key driver for Nokia to start working about maybe 5 or 6 years ago, very heavily with the utility segment to bring that technology to that segment, to those verticals. Back then, the actual understanding was that LTE was a commercial carrier solution only, that it wasn't necessarily ready for or had the capabilities to be deployed by a single enterprise. It was too complex. We actually debunked all of those myths, and we brought the first trials for some of the customers in Missouri for a customer that actually covers 2 states, Missouri and Illinois, and they were very happy with the results they saw, because it was not only a proven technology, everybody uses their phone every day, but it was actually done such that all the actual limitations that commercial carriers impose in order to provide a service to millions of users can be overcome. The technology already provides all those mechanisms in order to provide support for really low latency, high availability, prioritization, and to the point that Dave was making earlier, FirstNet, for example, is one of those networks that was built for first responders using LTE embedded mechanisms and architecture characteristics. There was not a different network that was deployed. It's the exact same technology. It's just that FirstNet turned on those switches that actually made the preemption, the prioritization, and the availability on for all their customers, for the first responders. So the same thing applies to the private LTE or private 5G network, where the utility controls all the security policy and the actual types of mechanisms to ensure that each of the use cases will get the resources that it requires in the moment they require. Having LTE plus additional technologies like narrowband IoT and CAT-M, or LTE-M as it's also known around the world, expands the capacity as well to support additional use cases. Many devices now come into the market in the form of sensors, for example, that are very cheap to deploy and that come with batteries that last for 5 years, ensuring that you do not really need to worry about bringing power to them. It's becoming a very helpful tool for utilities to understand and visualize, in some cases, the status of their devices and their infrastructure. There are, for example, some sensors that look at the health of the poles, look at the humidity, look at the actual tilt of the pole, and see other types of characteristics that ensure that when you are now rolling all your crews to fix something, you know where to go, rather than having to roll them without any kind of guidance, and then basically spending all those man hours, as well as bringing all that in, supporting infrastructure tooling and trucks and everything else to places where they don't really need to do anything. So the efficiencies are being improved. So that's a market benefit of actually deploying the sensors. But at the same time, it is something that requires its own network. It requires its own set of communication tools. But given the type of data that these devices or these sensors are transmitting on the network, they can easily overcome the actual network because of the number of they have. There's millions of poles for any utility that is deploying in a large enough type of service area. So having that many type of sensors deployed in a network could very easily choke up a network. So they use different mechanisms. And that's one of the characteristics of LTE, where you have the traditional LTE and 5G access methodologies to the network that can be, in a way, tweaked and shared by using narrowband IoT and LTE-M that are really focused for this type of actual communication devices. So now you don't really have to worry about deploying millions of sensors while still deploying maybe tens of thousands or hundreds of thousands of other devices, because they can share and they can cooperate and live without having or any effect within each other. one of the things that is very important to understand when we're deploying an LTE network or a 5G network is that while the technology and all the mechanisms are presented right now, and they're defined by a standardizations group defined called the 3GPP, the access to the network services and how many use cases can be deployed really depend on spectrum that's available. So to Dave's point earlier, he talked about CBRS. CBRS is the shared spectrum that's become available for anybody that wants to deploy a wireless network that's based on LTE or 5G. Because CBRS, again, is just spectrum. It doesn't really need to look into what type of technology you're using. So from that perspective, it's great. But at the same time, it actually has its own set of rules that you must abide by regarding power transmission levels, as well as how many users can really operate in the network and how many levels of priority you have for the ones that actually bought a license for it, or the incumbents like the Navy that will have restrict access to certain amounts of that band. So there are rules. And so some of the use cases will operate without any problem within those rules. Some of them may be affected depending on the location of the network that is being deployed. So all of these things, all of the use cases that we're talking right now, all the technology and all the good things about having a single managed network or security, as we will talk a little bit later, or deploying narrowband IoT or LTE-M type of sensors, really depend on how much spectrum is available. There are other options, licensed spectrum, like the one offered by Anterix, for example, 900 megahertz. There's other types of spectrum options available in the 700 megahertz range or in the 600 megahertz or even higher. But that is kind of the trick part right now when deploying an LTE network is where is spectrum available within the United States and how much is going to cost to acquire it for use. So barring that variable, and which really would take up an entire webinar on its own to discuss what options are available, really the idea is that if that's not a problem, you can deploy a network. But deploying a network, and we'll see this slide later on, really relies on having, an LTE network that is, relies on having a backbone infrastructure that actually provides the connectivity of all those towers, of all those end devices that are going to be connecting to the towers via RF, but all that traffic has to be wired somehow, somewhere back to the data centers. So that's where we have the wide area network, and this is where Nokia started working many years ago, providing a robust technology like IP and PLS that works either within optical or microwave or any other type of link that you can think of to provide that connectivity to the base stations. And that not only applies to carriers, but also applies to a lot of the utilities that were actually deploying their own field area networks using other technologies such as WiMAX that really were built in order to support not only the quality of service requirements for all the different types of traffic that were going to be traversing that network, but also to meet some regulatory requirements like NERC-CIP, for example. So having said that, this slide shows a little bit about how when we deployed the networks, it became an adaptive network based on different types of technologies. And the technologies were used for supporting use cases like teleprotection, for example, where definitely optical networks are required. And once you've deployed an optical network, definitely you can take advantage of it by using DWDM or CWDM, for example, increasing the capacity of that fiber that you deployed. So that's where we start as being the core of the backbone, which can be extended or supported in backup for microwave links, for example, and also extending that so to areas where fiber was not feasible to deploy because of the cost of the fiber. Having newer type of technologies being deployed, like, for example, distributed energy resources, either being offshore or onshore wind farms or the solar farm, this actually augmented the need for further communications with either fiber or with microwave links, or extending it to the last mile to get to all the distribution points, the poles, that would be actually done by LTE or 5G nowadays. That is the current model that we use from a connectivity perspective, and this is something that actually comes outside of a single type of technology encompassing an end-to-end solution. Because the utility, for as much as they would like to deploy an LTE network, It really doesn't make sense if they don't have a backbone network that will support all the traffic coming from the grid. So having an end-to-end solution, being able to monitor and look at the faults and look at the survivability of that network from where the data is generated to where the data is consumed, it is very important. And that's what we have done with Nokia for the last 10 years and 15 years actually for smart grid deployments. In a lot of cases, these new technologies and the way they're being deployed can also be sources of new revenue. And depending on the type of utility it's deploying this technology or how some utilities have spun off, for example, in the case of Southern Link is basically the communications arm of that company in Alabama, you can actually deploy additional services like UTelco. And UTelco involves bringing connectivity to the community, bringing actual access to, say, people that couldn't go to school during COVID, and they really needed to communicate to do virtual schooling. So that type of models, as well as extending for potentially providing additional services to carriers that really don't have the technology or they don't have the facilities and the assets to get to all those little corners, especially in rural areas, that's where you now have the capability to do that, and we have the portfolio to help that out. Open access provider to fiber, for example, is one of those use cases where we are seeing deployments from utilities that are deploying or that are leveraging the deployed fiber that are actually using that to provide a middleware service, so to speak, for the carriers to connect their 5G small cells and use that infrastructure. Smart cities is another very important development that we've seen in the last couple of years, where now everything is becoming automated. It's part of the Industrial Revolution 4.0, in which automation drives a lot of the technology because machines are talking to machines, and the automation really ensures that things are going to work out properly. Smart lighting, for example, is very important. Waste management, water management, smart parking, and security cameras are all connected now with potentially hundreds of thousands of sensors now that will allow you to know where there's a place where you can park while giving you the camera to see that where you're parking is a safe spot, that there's not going to be anything happening to your car, for example. And then but when the city is going to have the lights working properly, and you will be able to even connect to Wi-Fi while you are visiting downtown, having all of that automated without having to have any human interaction, working 24/7, 365, it's very important now for a lot of people. So those are new sources of revenue. A lot of those assets will be owned by utilities, and that's how they actually could see, in a way, their infrastructure be put to more service than any other time that you would see in the past. This is really achieved by the large type of offerings that Nokia has from a portfolio perspective. Like I mentioned before, from an optical perspective, DWDM, we have microwave for all kinds of different frequencies, being licensed or unlicensed bands. The PON, which is the passive optical networking, that now got to 25 gigs. So now the technology is there to bring 25 gigs down to every home if needed. Now, a lot of people know have 1 gig fiber. Just think that we can get to 25 gigs now, and all the systems that are actually related to the typical data management and data traffic by like switches and routers using IP and MPLS that will support all of this backbone infrastructure that can extend to the field by deploying LTE or 5G. All the backend applications to ensure that the systems are working reliably, that they're working properly, that you can actually do software upgrades, and you can manage all of the configuration depending on changes required by either regulatory entities, like in the case of utilities, or by doing just simple maintenance over the air to devices like sensors and other types of wireless access points. All of that technology is brought in by Nokia. So we're just not focused on a private LTE or a private 5G function. However, that is what we're talking about now. It's private wireless networks for electric utilities. And that's really building on what I mentioned earlier. This is a subset of those use cases that we talked about, grid modernization in the second slide. And really, they cover a whole lot more of what really we're looking into from a customer perspective, from the verticals of the utilities, on what use cases we want to have. we have now seen at least maybe half a dozen, more than half a dozen, actually, a dozen to 18 different customers that have deployed some of these use cases with specific interest in distribution automation, synchrophasers and FLISR, power line protection, as well as AMI. And now we're seeing more and more people looking at LMR upgrades from their legacy service that they had. So all of this that we're seeing is driving this LTE market very quickly. And I don't know if we've seen any questions so far, but I just want to make sure that I'm not really talking nonstop here. So in any case, we're also seeing additional use cases like drones and UAVs that are being used for specific utilities that actually want to do transmission line inspection and vegetation management, for example. That used to be done traditionally by helicopters, but unfortunately, either to crashes or the high cost of maintaining a helicopter fleet, they're looking at these other options that will give the exact same type of functionality, but with less risk and obviously less expenditure. So those are some of the use cases that are specifically being driven and being taken and validated within a private LTE network. Again, this all depends on how many use cases you can put into one single private LTE or private 5G network on the amount of spectrum available, as I mentioned before. So one of the things that we've seen in the past is that, again, back to this slide, we've actually been able to offload quite a bit of use cases like traditional SCADA and AMI to narrowband IoT, which has significantly opened the capability of deploying an LTE network for other use cases that have more requirements when it comes to data throughput or availability. Some of those technologies are really storing forward like mechanisms that allow the data to stay in place if there's no communications path available, and that helps out with the survivability of that information, like AMI, for example, which in turn opens up the capability of the network to be available for constant polling on the new synchrophasers, for example. So again, this slide really is to show how the evolution comes down to the bottom use cases that you can see from distributed generation, from transmission tower monitoring, and potentially with 5G in the future for teleprotection, for closed circuit TV, and in the transmission substations to controlling all the relays and all the potential devices that are there for RTUs and RTAGs. We also have expanded on the Wi-Fi, services when you deploy an LTE network and you use that LTE router as a hotspot to connect to other devices that are not necessarily LTE capable, such as laptops. Not all the laptops right now have LTE connectors. So you can actually do hotspotting using Wi-Fi for the mobile workforce that's out there with the tablets or the mobile data terminal units that they're called. From that perspective, and moving on, like I mentioned earlier, with narrowband IoT, you can also support additional use cases from AMI and the sensors and the poles. So these are really the way that we've been testing, we've been deploying the use cases for utilities, and we've been using LTE and 5G interchangeably within this presentation. But it's important to understand how they are different and where the line should be drawn on what technology to use. LTE started 20 years ago, almost 21 years ago. It's part of the IMT 2000 initiative from the 3GPP, where we moved from the 3G into the 4G world. That's where LTE started. And as you can see on this slide, it actually started with 150 megabits on the downlink and 50 megabits on the uplink, because at that point in time, that's really what people required. It was throughput, nothing more than that. LTE, however, has had 20 years to evolve. So with the first release of LTE, which was release 8, all the way to the last release of LTE, which was release 15, there's been a lot of change on what is being offered. For example, just to start with the capacity and the throughput of the network, we went from 1.5 gigabits per second in the downlink to 300 megabits per second on the uplink. That's achievable now. We've actually seen that, although not necessarily everywhere, but we've seen this type of performance with devices that are available in the market right now under ideal RF conditions. That would be part of the release 15, for example. We've also seen a dramatic drop in latency, whereas the first iteration of LTE really didn't take latency into consideration. It was more about connectivity. Latency was dropped to less than 10 milliseconds within the release 15, which is also known as 4.9G. And this is very important because a lot of the mission critical applications that support utilities, or that utilities need to support in order to run properly, actually do have stringent latency requirements that are met by this technology. And as you can see, also there's a reliability from 3 to 5 nines, which was before quite difficult to achieve, especially at the beginning with LTE, just because newer technologies always have their glitches. Now we're at a point in which all of those glitches have been worked on, and now we can have up to 5 nines reliability. Granted, that actually relies on the network design, but it also is something to speak about, the actual robustness of the technology by now. Additionally, one thing that was actually included within release 13 and on was that sensors would be supported, and that's where narrowband IoT really started. That's a low data rate and long battery life technology, as I mentioned before, but it was something that was brought on because a lot of the applications and the term IoT really started popping up back then, and people wanted to have machines talking to machines in order to ensure that things were working properly. Just because of the sheer number of devices that were starting to be dropped in the network, humans really weren't made to keep track of that many. So machine-to-machine communication became a reality, and with that, narrowband IoT and LTE-M were there to support that type of communication in order to share that same resource, that resource that we talked 2 times already about, which is spectrum. That's really important to be able to use it properly and intelligently. From a use case perspective in the utilities, right now, 98% of the utility use cases that we've seen actually are supported by LTE. And if you look at 5G, all the evolution that has taken place within LTE was actually moved to the next step. So now, while there were some architectural changes, all of that evolution that we saw in LTE was really the actual culmination is 5G. So there are very few, I would say, changes on it. Now, if you look at the actual triangles there, we're talking about enhanced mobile broadband. Now it's called extreme mobile broadband. Machine communication became critical machine communication, and the IoT and sensor side became massive IoT. And I'm going to explain why on each of these areas on where things have been improved and where things will be improved, because right now LTE is a finished standard. 5G is not. 5G is still in the process of being completed, and it will be done with release 18 in 2023 potentially. I don't know exactly when. The dates were set before the pandemic, and now time is a little bit in flux because all the effects that the pandemic had with everything, including the technology and including the people being able to not talk to each other, or at least more difficulties to do what they used to do as a norm, getting together. One of the things that we see is that, from a private LTE perspective, like I was talking before, not only all the use cases, but the actual ecosystem of devices is right now supported with 4.9G. With 5G, we've actually improved not only the enhanced mobile to extreme, going to 10 gigabits per second on the downlink. So it is a huge increase on the capacity of the actual network without really changing anything on the I would say, making big breakthroughs on newer technologies, just using the same RF. Critical machine communication became a critical requirement by distributing all the functions that were held before within the core of the LTE network. Now with what it's called the distributed model, latencies of lower than 1 millisecond can be achieved. And this is important because with new use cases like vehicle-to-vehicle communications for automated vehicles, right, self-driving vehicles in the roads, will be key to maintain that level of latency, because devices would have to be connected to each other near real time. So that type of new use case is going to be enabled by the critical machine communication. And that is that evolution that went from the machine communication from a less than 10 milliseconds to less than 1 millisecond now. So that's the evolution on that side, which is really still being worked on. Then on the last triangle on the left, we have massive IoT, where initially a number of sensors were to be counted within the thousands or tens of thousands. Now we're talking about millions of sensors connected to the same base station. So it's a better way of handling the explosion of the use cases when it comes to different types of sensors, where we see now sensors everywhere. If you've seen in your household, probably you see that now that your refrigerator, your blender, and anything else that uses electricity is able to connect to the internet, and it allows me to actually brew my coffee while I'm on the road, just when I to get home for a nice fresh cup of coffee. That's something that now requires connectivity. And that massive number of IoT devices is what's going to be supported by 5G. So we went from tens of thousands to millions of devices. But if you look at it, it's still the same triangle. It's still the same set of devices, of the use cases and the actual groups of the use cases that are present. So from that perspective, when we look at LTE and we look at 5G, there is a path. There is a migration path, where now a lot of utilities are looking at deploying LTE just because of the breadth of the ecosystem devices that is available, plus that the actual LTE standard is been concluded for many years now. So this is a solid system. And now 5G is just finishing up. It's just starting to have more and more devices from an industrial perspective. Most of the devices you see from 5G are handheld phones that take advantage of the extreme mobile broadband, but you don't see that many about really looking into critical machine communication or the massive number of IoT devices out there, just because those standards are still being developed. So from that perspective, we have seen that a lot of utilities are deploying 4G systems with the idea to move into 5G systems. And what are those systems? Well, those systems that Nokia brings to the table come in two flavors. The ones that is focused on simplicity and the one that's focused on more of a need for full control, something that's more customizable. And these two solutions really come to the place in which type of environment it's going to be deployed. A lot of mission critical networks will look at the more customizable type of deployments, like utilities, for example, where they want to tweak every single knob that LTE allows them to tweak in order to meet the requirements of the use cases. However, a lot of that technology also, and because we've seen before, it can be a little bit daunting for the people that don't understand LTE just yet. And so we have a solution that's focused on simplicity that really resembles a plug-and-play service, like a Wi-Fi controller now that you can deploy in any enterprise. So the possibility of migrating from a simple system to a fully controllable system are there. It's just software, really. So all of the actual characteristics of both of these systems really rely on being the same platform, just in different packages that you can bring to your enterprise. We have the latest generation of LTE available in both, and they're actually upgradable to 5G as a software upgrade. No hardware needs to be changed, both on the core as well as on the radios. We are the leading small cell portfolio provider, and we have actually a cloud core, which allows us to do not only the virtualization in different types of flavors, as I just mentioned, but also if the enterprise needs, we can offer a fully cloud-based solution. We have the largest range of spectrum options. Here in the US, we cover all the license bands, not only from a carrier perspective, but also the ones available for other types of networks like private LTE and like Anterix, CBRS, others like Band 71, which is the 600 megahertz, etc. And this is something that Nokia has been famous about. It's basically supporting pretty much every band that's available in the world that has been officially deemed as an LTE band or a 5G band now. And we have a complete IP MPLS and optical transport solution that complements this deployment, because you really need to be able to bring that data back to the data center. End-to-end management and orchestration is what really defines the solution as an end-to-end solution for our customers, bringing not only the monitoring and the fault management and all the actual configuration management from the end devices to the radio access network, which is the base stations, to the core, and every single piece of hardware in between it, being optical, microwave, or other type of Ethernet routing. That's the end-to-end application management and orchestration that allows us to, with a single click, to deploy services that actually will create the connectivity from end device to data center servers so that the simplicity will really make sure that your systems are up and running and they're monitored to the level of reliability that the utility may need. In talking about our NDAC solution, which is the simple solution that I mentioned before in the previous slide, it's really meant to be a quick to deploy and quick to market solution that brings everything that we would need to deploy a private network, including spectrum. One of the things we talked about is that either it's a shared spectrum or it's licensed spectrum, but in both cases, we need to have contact with the spectrum holder. Nokia does not own spectrum. There are very few people who actually own spectrum. And in the case of CBRS, it's owned by the FCC. It's controlled by the FCC, I should say. But it relies on the spectrum access service providers, which are the SAS providers. And so the Nokia NDAC solution does bring all of that already as part of the solution in case you want to use a license band through Enterix, you want to use a license band through Globalstar, or if you want to use CBRS. And we bring not only all the actual hardware, but also the spectrum negotiations already as part of the package. That way you can deploy your network without having to worry about who I need to talk to about SAS services and what really is a SAS service. It's really about what use case I have, where do I need to plug in these things, and how am I going to operate this very quickly to ensure that all my applications are going to be connected. The key is that we have all the core components that will ensure an LTE or a 5G network to operate at the most critical level within that industry, the utility in this case, and we host all the management platform in the cloud such that it can be reachable through any browser, just like you would do your email, for example, using Office 365 now. And so something like a distributed deployment becomes really easy to do because you can replicate what you do in one single site in other sites, and that is for networks that could be deployed in different types of regions or different types of states or in any other type of network that you can think of, and you can manage it all from the cloud. Again, like I mentioned, it's the end-to-end services that we pride ourselves on when we bring this product because it includes spectrum, it's simple and easy to deploy, it brings a set of ecosystem devices that actually work with 4G and 5G industrial devices. I mentioned that the 5G industrial device portfolio is still a little bit limited just because of how the standards are still being developed, but we do have some of those, and we really do provide the full control of a dedicated network that it's actually going to be running within your infrastructure based on a cloud architecture, but provides full visibility and control in the connectivity of the devices and the applications from a single management interface, which allows you to look at that easily and see where there are problems or how to reconfigure things. From a Nokia Digital Automation Cloud overview perspective, one of the keys about this offering is that it's not focused on connectivity only. So we not only provide an LTE network or a 5G network components and radios and the core, we really do provide additional services. And that's really the key of this deployment or this product offering is that we actually do have other types of applications that run on top of that. So we have, for example, the drone application that actually allows you to not only control the drone, fly the drone, and create all the policies of who can fly and where it can fly, right on top of the connectivity platform that is provided by the actual LTE or 5G network. We also provide a communication services for devices, be it cell phones or be it handheld devices, a very simple and a very complex offering depending on what the customer needs, but you're bringing push-to-talk and push-to-video applications as well. And that's all based on the microservice framework that allows you to not only bring these applications, like I mentioned, just two of those, but also to increase the capability of deploying your own applications based on whatever connectivity needs there are. Think about maybe potentially managing robots of different kinds of automation lines or other types of control or workflows that you need to enable within your area of deployment that will be open for you to do without having to worry about how is the connectivity going to be taken care of. And that is the key of the actual NDAC offering. So I just want to do a quick time check. I know we have some slides left, but I'm going to jump on those. I'm going to share all of these slides, which basically show the devices that are available. And really wanted to thank you for the time. And I wanted to pass the control back to Danielle for closing remarks and if there's any questions.
I will now turn this over to our attendees. Does anybody have any questions for either Dave or Mauricio? You can put them in the chat section or the Q&A section. Looks like you gentlemen covered everything because I am not seeing any questions right now. So thank you everyone for joining our presentation today and for your interest in Nokia Private LTE. Hope that everything was informative for everybody. If you do have any opportunities or projects that you'd like to discuss, please feel free to reach out. Nokia has made it very easy to set up this private LTE solution anywhere and everywhere, as Mauricio had explained, for solutions that are big and small. So really no opportunity is something that we're not looking to look in with you. They're very easy to engage, and with our partnership, we now can give access to all the resources that Nokia makes available for you guys. So definitely very excited to work with you on your next private LTE project, and we look forward to speaking with you soon. Thank you, everybody. Have a good rest of your day.
Thank you.